So now we're ready to discuss Model 2, the full model. So this model extends Model 1, and what it's going to do is it's going to introduce the main effects of the 5 sociodemographic characteristics: sex, race, education, income, and age. And so by introducing the main effects, we're going to decompose the total stratum means that would be modelling and predicting. We're going to decompose each of those into 2 parts. That part which is due to an additive contribution from the main effects, and that part left over which is due to interactions, 2-way, 3-way, 4-way, 5-way interactions, if we like. So it's a decomposition approach, and by doing so we can work out the relative importance of interactions in general. And along the way, this is going to optimally predict the stratum interaction effects. So we're going to have the same kind of borrowing strength, empirical based type prediction, which controls for small sample size. And the shrinkage property there will control for type 1 errors of inference, because with the interactions, we're always going to be less likely to see significant differences. And they're going to be less precisely estimated in general. So we need to be particularly careful here about type 1 errors of inference. And so it's great that we've got some built-in control for that. So the full model is once again starts off in the same way with, and I can get my pens out to help us. So I'll just do that. So find a pen, find the highlighter, get my yellow highlighter. Okay, so once again, we've got the bodily mass index for individual I in stratum J, and that's modeled as a function of the unknown population true mean BMI for that stratum, the quantity of fundamental interest, plus a residual which takes you from that true mean in your stratum to U. And they can be positive or negative quantities depending whether you're above or below. So exactly the same as before. But now we're building some systematic structure into the stratum means, which is we're adding gender, and so we've got a dummy variable for being female. We're adding ethnicity, so we've got dummy variables for black and Hispanic, leaving white out. So we're putting for each categorical variable dummies for all but one of the categories, just like in linear regression. So for the 4 categories of education, we've left out the dropout dummy, and so we have the high school contrast, the some college and college degree categories are in there. And then for income, we leave out the low income band, so the reference is going to refer to low income as well as male, white, dropouts, and the youngest. And then we've got income dummies for low to mid income, mid to high, and high. And then age bands, the youngest ones, the 18 to 29-year-olds, that category has been omitted, so they are defining the reference. But relative to them, we've got the young to mid-age, the middle age, and the older age group there. So those terms in red are the additive effects of the sociodemographic characteristics. Okay, but the true stratum means are going to be partly formed by additive effects and partly formed by complex interactions. Now all the interactions are going to be captured now by these UJs, the bit left over, because that's a discrepancy between the true mean that we're interested in and that part of the mean predicted by additive effects. So I think this slide is kind of saying the point I just made, which is that the fixed part of the model with the explanatory variables is capturing the additive effects of the characteristics, whereas the UJ, the stratum random effect, its meaning is now changed because we've changed the model, and it now refers only to 2-way interactions and above. And so these are going to be stratum-specific interaction effects, which are going to capture how each stratum deviates from what is implied by additive effects alone. So here are the results for it's called Model 2, the full model, Model 1 being the previous model. So as you might expect, the regression coefficients aren't particularly different from what we'd get from linear regression. So I'll just quickly go over those there. So we've got all 5 variables in, so the interpretation of each coefficient is having controlled for the other variables. So having controlled for ethnicity, education, income, and age, women are predicted to be no higher BMI really than males. There's no significant difference there. But of my 382 strata, those which are black strata are on average, all else equal, seeing an elevation in their mean BMI by 1.8, and that's significant, and that's 1.8 versus whites. Hispanics versus whites, 0.7, so less than half this. And in terms of the education gradient versus dropouts, those strata characterized by some college, well, that's a little bit less, but not significantly so, but college degree, that is significantly less by 0.8 of a BMI point than dropout. So normal kind of interpretation, except that these are kind of characteristics of the strata. So we're talking about the 382 strata and how they systematically differ from one another in terms of mean BMI and to what extent this is attributed to the specific characteristics of the strata here. So let's clear out those drawings. Let's proceed to the next slide. The next slide has income and age, the last 2 variables here. So what we see here is that for income and the income gradient versus the low income reference category, the only significant difference really is when we come into high income. So the approximately quarter of strata which are high income strata versus the approximate quarter of strata which are low income, we're seeing a systematic mean difference, even though other categories are varying when in this, we've got all that diversity, but it's only 0.6 of a point. Age gradient is in contrast much stronger, so relative to the youngest group, clearly all 3 of these categories are significantly different, but the real big differences are when we look at the 45 to 59-year-olds who have higher mean BMI than the young by some 1.8. So those strata characterized by older individuals, averaging across all the other variables, are systematically higher BMI than the young. So those regression coefficients, like I said, it's a bit like linear regression, but really we're conceptually viewing these as characteristics of the strata. Moving on to the variance components, remember previously these quantified the degree to which the strata means varied across the 382 stratas. Now the interpretation changes. Because I've put in the main effects in model 2, that estimate drops to 0.6, but the interpretation has changed as well. The interpretation is now, to what extent does population mean BMI vary across the 382 strata over and above those strata differences that we expect or are implied by the model by those substantial additive effects. And so that's only 0.6, which is a third of what it was previously, 1.8. So what we can really say here is I can explain really about 2/3 of the mean differences by these additive effects, which means that 1/3, 0.6, is unexplained by additive effects, and so is attributable to non-additive effects, interactions, 2-way interactions, 3-way interactions, 4-way, 5-way interactions. And that's what this PCV statistic is here. This PCV statistic is saying what proportion of the stratum variance is explained by the main effects, and you can see it is 0.67, so which is 2/3. Okay, let's clear out those and shift over to there's a formal slide explaining the PCV. So this is really spelling out for you, just so you have it, that as we drop from a stratum variance of 1.8 to 0.6, that's a reduction of 1.2 divided by the 1.8, and so that gives us this proportion of 0.67, which is 67% of the variation attributed to the main effects or additive effects, whereas that must mean that the remainder is attributable to non-additive effects or interaction effects. It's called the proportion change invariance, a useful statistic to report. At this point, you might be wondering, well, wow, you know, those 5 variables collectively are explaining 2/3 of the differences. But you might be interested in, well, of those 5 variables, which one is doing the damage? Okay, you can kind of look at the coefficients to try and kind of get a sense of it, but a kind of a slightly neater way perhaps of doing it is to actually refit model 2, but with one variable at a time. So you put in just sex, take it out. Put in just race, take it out. Just education, take it out. Just income, take it out. Just age, take it out. And in each case, the between stratum variance will get explained away, but by different amounts for different variables. So it's a bit of a horse race. And so of my 5 variables, I've now sorted them into the order of explanatory power, so race, age, education, income, sex. So race explains 33% of the differences between the 382 strata. Age in isolation explains 24%, but then education in isolation is only 8%, income in isolation only 4%, and sex in isolation doesn't explain anything really. So this is a kind of a nice way of establishing the relative importance. These are a bit like R-squared statistics, but R-squared statistics for the between stratum variance. And this brings us back to our lovely league table of our top 5, bottom 5, but this is no longer in terms of the stratum means. We're now focusing on the stratum interaction effects. So this here should say really uj rather than beta 0j. So that's just something for me. And I'll write that down now to correct, always spotting things. And so these are stratum effects, and that's why the numbers are much smaller, and that's why they're now centered on 0, because they are how each stratum, okay, so for example, stratum 272, how does its optimal predicted mean BMI differ from that implied by the additive effects? Well, it's 1.4 points higher. So we're able from this analysis to identify strata whose means differ from what is implied by additive effects. The ones in the middle of the distribution, additive effects is working really well, but the ones in the tails are where we see greater importance of these non-additive effects. And interestingly, the top 5 are ones with the most extreme positive interactions, doing higher than otherwise implied. These are all relate to female individuals, and low income is an important thing. Okay, so there's some kind of systematic patterning there, and also black. So these are kind of marginalized. Once again, these are kind of marginalized characteristics, and drop out as well. So there's quite a lot of marginalized characteristics that we're seeing here. No young age. And then the bottom half of the table, we're seeing kind of privileged characteristics a bit more, perhaps of black, of degree, and we've got some high incomes. But we're also seeing some, male and degree, I should say. We're also seeing some black with marginalized characteristics in there. A dropout and low. So it's a bit of a more mixed thing because we have stripped out the additive effects. Okay, but what we really want to know is there's some kind of patterning to the interactions which remain. But sex by race appears to be an important one. Here is the caterpillar plot for those interaction effects, the UJ hats. So these are, as I indicated earlier, they're much smaller quantities because they're just how each stratum deviates from expectations. They've got kind of pretty wide confidence intervals on. Nevertheless, we are getting some statistical separation. Up here, we've got a few strata who are significantly above the mean, and the mean of 0, which is 23 or 6% of the sample. And we've got some 15 or 4% significantly below the mean. So, I mean, if nothing was going on, you'd expect 5% by chance. Here we've got more like 10%, and actually, because of shrinkage, this is really kind of quite suggestive that there are genuine interaction effects here. And the sizes are, pushing on for 1.5 BMI points in the tails, which is quite meaningful. But again, a word of warning. Remember, the Model 1 variance partition coefficient was just 0.05. And so collectively, between strata, there's a limited variability, just 5%. So the interactions, whilst they're important, they explain a third, which is quite a lot for interactions. They explain a lot of a little. Okay, they explain 1/3 of the 5% of variation in individual BMI. So it's just worth kind of always tempering our interpretations by that. This plot here is now trying to make sense of the structure of the interactions. So most likely these interactions is going to be two-way, three-way, four-way, five-way. The two ways are always going to be the most important. So each possible two-way interaction is considered here. So for example, sex by race, then sex by education, and then we just cycle through each pairing. And then in terms of these total interaction effects, I'm in each of these, I'm plotting the mean by the categories of the interaction. So sex by race is two categories of sex, male, female, by 3 categories of race, white, black, Hispanic. 2 by 3 is 6 in total. So there's 6 subgroups or cells. The female black ones are showing positive interaction effects on average, pushing on for over 0.3, whilst male blacks are more like negative 0.3. And so it turns out that sex by race, what this is suggesting, is the most important interaction in isolation. Then perhaps sex by income is pretty important. The least important looks to be something more like race by income. And so you can kind of look at these different pairings and get a sense here of where the action is. Sex by race, sex in general, because sex in general is going to be this block of 4. Okay, that all appears quite important. And then, of course, we could put those two-way interactions into the model, and we can probably do that. We're going to struggle with 3, 4, 5-way interactions, putting them in the model as fixed effects because you're cutting the data over finer. But it's a big old data set, so actually we could put in all these two-way interactions. And if we do, what we find is that some 90% of the total interaction variability is attributable to the two-way interactions, this set of 10. And then we can do what we did before, which is to refit the model with one interaction at a time. First do sex by race, then sex by income, and so on. Now, when you do that, we see actually sex by race is accounting for 43% of the total interaction variance. Sex by income in isolation, 26%, and then we're dropping off to 12, 10, and something like race by income in isolation is only explaining 3% of the interaction variance. So we get a sense here of which interactions are most important, which intersections to kind of to think about and be aware that we're going to see quite different patterns across combinations.